Hello, math people. Just watching Crazy Russian Hacker, and though he says don't try this at home, you definitely should try today's at home. At least part of it. At least part of it. Today it's lesson 65 using the quadratic formula. I'm going to be sending you along instructions for writing a program on your calculator. Oh, some of it you might just have to keep working at to figure out. But there's instructions on how to write a program to have it do the quadratic equation for you. And you'll get a little bit of, I guess, experience using the program tools there, inputs and outputs and stuff like that. So check your email for that later, and you definitely need to at least give it a try. Even if you don't get to work, you can send me a picture of what you did try, and we'll figure out how to fix it. Okay, I'll show you how mine works. Go to Programs, and I got, there's one called Nunchuck. Now I'll go to Quad Equation. I made it myself. And then it says, okay, what do you want? And it asks me for some numbers. I give it 1, 2, 3, or whatever my quadratic, I'm so sorry, whatever my quadratic equation happens to be. I hit enter, and it gives me some answers, and then it gives me a victory message. You can choose to put whatever victory message that you want to when you write your own program. Alrighty. Quadratic equation, quadratic formula. This is the thing that James Tanton, in helping us figure out how to do quadratics using drawing a picture, that he said he's never actually memorized this. And I don't really believe that. Because if he took math at some point, I'm sure he had to memorize it. He was saying all the stuff, other stuff he had to memorize. I'm sure he did. But he doesn't like it, and he doesn't need it. That's what he was saying. The quadratic formula starts with writing out the general or the standard form of a quadratic equation with our coefficient a, b, and our constant c. And then working through by completing the square to solve for x. Okay, that's it. So you can see here there's some work to do. There would be, one of the steps would be moving the c to the other side. There's going to be some division here by a. So we have x squared plus b over a x equals negative c over a. That sets it up for completing the square. We would take half of this and square it and add that to both sides. Half of b a is b over 2a. That part gets squared, so we would add a b squared over 4 a squared and a b squared over 4a squared there as well. The left side can be rewritten as x plus b over 2a squared, and over here we would find a common denominator. So we multiply this one by 4a to get negative 4ac plus b squared all over 4a squared. At this point, you're almost done. You just have to take the square root of both sides and keep going. You take the square root of this side, you get that. You take the square root of this side, you'll get that. You take the square root of 4a squared, you get 2a, and you can see that we're almost done. The last thing we have to do is finish it off. You don't need to know all that. I just improved it to myself that I can do it. You used to have to memorize the process and be able to show on the test that you could go from beginning to end. The last step is this. Coming up with the formula. X equals negative b plus or minus the square root of b squared minus 4ac over 2a. You need to have that memorized. It's on your algebra sheet here, right there. Quadratic formula. Nevertheless, this should be something that is right there for you. There's a couple of interesting features in here. One, this part under the radical sign, b squared minus 4ac, is pretty important. It's called the discriminant. It'll come up again in lesson 74. That part underneath the square root sign will tell you what kind of answers you're going to get. If it's a positive, you're going to get 2 real number answers. If it is 0, you're going to get negative b over 2a as your answer. And if it is negative, you're going to get 2 complex conjugates for answers. So it determines where the picture will be on the graph. Is your parabola going to cross in 2 places? Is it going to cross or going to touch in 1 place, or is it not going to cross at all? That part, b squared minus 4ac, will determine that for you. So it's pretty important. Another thing that we see here is that we've got negative b over 2a. That should look familiar to you because that's the that's the address for finding the axis of symmetry for a parabola. It's negative b over 2a. Yep. And the fact that we got plus and minus means that we're supposed to have 2 answers. There's a thing in math called the fundamental theorem of algebra, which says that if you've got an x squared type of problem, you're going to end up having 2 solutions. They may be complex, but you still get 2 solutions to this. This is a generalization then of any quadratic formula. If you can write it in standard form, then you pick out what a, b, and c are, and then you plug it into the formula, and you solve by hand. There's some that will work out very nice and cleanly. You'll get a couple of whole number answers. They don't always work out that way. If they do work out that way, you can use your program. If they don't work out that way and you get decimals, you need to do it by hand. I need exact answers here today. Exact answers. Okay, so we're looking for this producing for us 2 answers or solutions, or we call them roots. Okay, so we'll have negative b plus that over 2a and negative b minus all that over 2a. We'll have 2 potential answers there. So let me give you a quick algorithm. I don't really like algorithms that much for algebra students, but here we go. Step number 1 of any of these types of problems would be to write it in standard form. ax squared plus bx plus c equals 0. So the equation might be like have x squared and have the rest of the stuff on this side. Just put it all on one side and leave a 0 on that side. Number 2. So there might be a little bit of rearranging to do in your equation. Secondly, identify a, b, and c. That is, I'll put off to the side a equals, b equals, and c equals. When you write your program, it'll prompt you to just give it that information, so you have to pull that out of the standard form of the equation. It'll be the coefficients there, and the constant right there. Number 3. Substitute a, b, and c into the formula. That is, we just start putting the numbers in there. If b is a 2, you're going to put a 2 there. You're going to put a 2 there. And you're going to have a and c. You're going to write them in, and you're going to start solving. Math is not hard. You just have to be a little bit patient. And then number 4, solve for x. Solve for x. That's it. That's it. You can do all these by hand if you want to. There's really not a whole lot of complicated math here. There's squaring, multiplying, subtracting. Only take the square root if you can, right? And division, adding, subtracting. It's pretty straightforward stuff. So you might want to pause and write those 1, 2, 3, 4 down, because I'm just going to demonstrate that process from now on. All right. I'm going to write this off to the side so that we have it on the screen. Square root of b squared minus 4ac over 2a will be what x equals. Alrighty then. So here's my first one. 9x squared plus 6x plus 1 equals 0. You can do a couple things for starters. I guess you could graph it, and you can see what it looks like. You can see if it crosses the x-axis, or if it only touches it once, or if it never touches it. I'll give you an idea of what type of answers you're going to have. Or you could do the b squared minus 4ac part first and see what if it gives you a positive, negative, or 0. But that's not what I asked you to do. I asked you to do 1, 2, 3, and 4. So number 1, it's already in standard form. Double thumbs up. Second, we'll pick out what A, B, and C are. A is 9, B is 6, and C is 1. Step number 3, plug the numbers into the equation. Okay, so x equals negative 6 plus or minus the square root of 6 squared minus 4 times 9 times 1 over 2 times 9. Okay, I'm going to leave that there. 2 times 9 is 18. That's not hard. 18. 6 squared is 36. That's no problem. And lo and behold, minus 4 times 9 times 1 is also 36. So we are in the know. 36 minus 36 is 0. Square root of 0 is 0. We can boil this down now to not needing to add or subtract anything here. Our answer, singular, will be negative 6 over 18, which is negative 1/3. This picture must do something like this. It's my guess as to what that picture looks like if you had graphed it. Looks like it touches right here, which technically means that the answer is negative 1/3 with a multiplicity of 2. I'm not going to worry too much about that today, but that's what that would mean if it just kisses the line. It's basically x plus 1/3 squared is where this thing must have come from, or something like that. All right. So that's the first one. There we got our answer. X equals negative 1/3. Only one answer this time. Usually there's two. Technically there are two. It's negative 1/3 and negative 1/3. Okay, that was fun because that was one where the discriminant, or the part underneath the square root sign, the b squared minus 4ac, was 0. Here's another one. 3x squared, minus 7x plus 2 equals 0. Now what would be fun with these would be to put these on Desmos and then just make a slider for A, B, and C and then see how it changes the picture. Maybe I'll make another video of that and you can see how that works. But we've already got it in standard form, so we got step 1 down. Step 2, identify A, B, and C. We got 3, negative 7, and 2. Step 3, plug it into the formula. X equals negative 7 plus or minus the square root of negative 7 squared minus 4 times 3 times 2 over 2 times 3. Okay, now we just start crunching the numbers here. X equals, that's a 7 plus or minus square root of 49. That's going to have to be a positive. And then we're going to take away from that. 12 times 2 is 24. And we'll do this over 6. Almost done. Let's go 24, or 49 minus 24 is 25. Square root of 25 is 5. And our problem splits up into two little problems. It will be 7 plus 5 divided by 6. or 7 minus 5 divided by 6. This is 12/6 or 2, and this here is 2/6 or 1/3. There are our answers, 2 and 1/3. This picture must go something like this. You can verify that by graphing it on your calculator, but it should cross at 1/3 and it should cross at 2. Two real number answers for that one, 2 and 1/3. Those are the roots or the solutions or and the x values, zeros, I guess this is the thing that we call it. All right, so once we had this being 0, once we had it being a nice, clean, take the square root of it type of number, a perfect square, sometimes it doesn't end up so nice, but thankfully we already know about complex numbers, so we're ready to go here. Step 1's done. Step 2, identify A, B, and C. A equals 3, B equals 5, C equals 4. Step 3, plug into the formula. X equals -5 plus or minus 5 squared minus 4 times 3 times 4 over 2 times 3. Now I can see right now that this over here is going to be bigger than 25, so this is going to end up being negative, which means we're going to have complex numbers coming up. So, -5 plus or minus, we got 25 minus 12 times 4 is 48 over 6. Okay, what's 25 minus 48? It'll be a -23. All right, so I'm just going to erase that and put in a -23 in that space. And there we go. There's our negative thing, and now we know what to do with that. We're going to call that square root of 23, which is prime, times the square root of -1, which is I. And we need to split this up into two pieces. And we need to write this in the right form for a complex number. So what we've got here is -5 plus or minus square root of 23/6 I. That's also a 6 over there. We'll just split up. We can write it like this, or we can split it up and have a plus version and a minus version. But you can see we've got two complex conjugates. We got -5/6 plus root 23 over 6i, and you got -5/6 minus square root of 23 over 6i. And those are your answers. Complex conjugates. Make sure on these ones that you write your answers in A plus BI form. Okay, there's A plus BI. Complex conjugates. Now, I don't know exactly what that picture looks like, but I can tell you that it's up there and it never crosses the x-axis. I can tell you that. I don't know where it is, but I know it opens up, and I know that it never touches the x-axis. Okay? That's what happens when that discriminant, this part right here, is a negative number. You get complex conjugates. All right, now that one was better by hand. If you asked your calculator to do that one, it would give you answers, but it would be a little yucky because it's trying to take the square root of 23. A final way to go about doing these would be to estimate answers by graphing. Estimate answers by graphing. And what I mean by that, well, you might have an equation that's something like, it starts off like x squared plus 2x equals 7. Okay? What you could do is you could graph x squared plus 2x in y1, and in y2 you could graph 7, and you can see where those two things meet. The first one is a parabola, and the second one is a line, and so hopefully you'll be able to find a couple of intersection points for that. Another way you could do this is you could just put that into standard form, and you could graph it, and you could see where it crosses the x-axis now rather than the number 7, and hopefully it will. The only problem though is that if you're searching for zeros, which you would do if you graph it and then you hit trace, or second trace I should say, then you're accessing the calculate function on your button. And if you use number 2 and look for zeros, yeah, you can do that. It'll give you a range. You look between here and here, and you find one, and you look from here to here, and you find another one. The only problem is that that is really no good for ones that have the radical on them. It's no good for ones that are like the square root of 23 or the square root of 7. It's not really going to be helpful because you're not going to get exact answer. That's what we need. We need exact answers. You need to give me exact answers. And it really won't help for complex numbers either, because there won't be any real number zeros. They'll be complex. They'll be conjugates. They'll be out here somewhere in the third dimension rather than something else. If you watch those videos on complex numbers are real or imaginary numbers are real, then you saw him pull his parabola up out of the sheet and it curved out, and yeah, we found a place where it crossed the complex plane. Anyway, that's the deal. I think most of these you can do by hand, though it would be fun to just check first to see if your computer program will work. Again, I'll send you a link, or I'll send you that in an email so that you get that. I'll probably just take a picture of it, and then if you have problems with your programming, go watch a YouTube thing on programming the TI-84 or the TI-83, or we'll have a little chat and we can talk about which buttons that you need to push to do that. Okay, have fun with that, and hopefully that's enough to get you going on your lesson today. Pretty straightforward, I think. So yeah, there you go. We'll see you later.